Hello students, these are the topic tests that we at Bodhee Prep have prepared for you to help you get a sense of how well you've prepared a topic. So once you've done the basic concepts and practice for the topic, that is when you take this test. Once you've taken the test, you refer to the video. This video will have solutions for the given test and a brief analysis of the test overall and questions as to what could have been attempted and the kind of time that you could take for a question. There are more than 200 topic tests available on the Bodhee Prep Android app. The link for the app is in the description of the video. So feel free to download the app and make use of these tests for your preparation. This video is about the topic's factors, and this is the test number 3 in the app on this topic. If I look at the overall test, I think it was a moderate level of difficulty test, and about an attempt of 6 questions, net correct would give you a 95 plus percentile for sure. The ideal time to attempt this test would be about 20 to 23 minutes. So basically, going from question 1 to 10 should take about 23 minutes, where I'll be able to choose my 7 easy questions and get 6 questions net correct. That would be the idea. If I look at the questions, the first question says compute the sum of the digits of the largest prime factor of 4 raised to power 7 minus 1. Now 4 raised to power 7 minus 1 can essentially be written as 2 square raised to power 7 minus 1. It becomes 2 raised to power 14 minus 1. Or 2 raised to power 7 square minus 1. A square minus b square is a plus b into a minus b. 2 raised to power 7 is 2, 4, 8, 16, 32, 64, 128. So this becomes 129 into 127. 128 plus 1, 128 minus 1. 129 will be divisible by 3. This will become 3 into 43. 127. If we try to divide 127, 127 is not divisible by 3. 7 ones are 7. Not divisible by 7 either. Not divisible by 11. And therefore this will be prime. So 4 raised to power 7 minus 1 is nothing but 3 into 43 into 127. We have to find the sum of the digits of the largest prime factor because 127 is prime. So the sum of the largest prime factor of 4 raised to power 7 minus 1 will become 1 plus 2 plus 7, which is nothing but 10. Again, I'd say moderate sort of a level question. All we have to do is factorize and we'll get the answer. And the solving time should be somewhere around maybe 2 odd minutes. Again, the point is, if you've done factors, you would have done questions like this, and therefore, I'm saying not very difficult to solve. Compute the product of the positive factors of 576. So what we do is, first of all, we try to factorize 576 and look at the 576 is 288. 288 by 2 is 144. 144 by 2 is 72. 72 by 2 is 36. 36 by 2 is 18. 18 by 2 is 9. And then 3 and 3. Therefore, 1, 2, 3, 4, 5, 6. 576 is nothing but 2 raised to power 6 into 3 squared. Therefore, number of factors of 576 will be 6 plus 1, 7 into 2 plus 1, 3, that is 21. Now, when we write all the factors, we have to find the product of the positive factors. When we write the factors, the first and the second factor will multiply to give us 576. The second and the second last factor will multiply to give us 576. Therefore, out of 21 pairs, we will out of 21 factors, we will get 21 by 2 pairs. The product of each of the pair will be 576, and therefore the overall product will be 576 n raised to the power number of products by 2. This is nothing but 24 squared because 576 is 24 squared. Raised to the power 21 by 2. 2 and 2 multiplied, 2 and 2 cancelled, and therefore this will come out to 24 raised to power 21. Option B becomes the answer. Again, if you have done the factor theory, this is a direct formula that is used. So this should not be a difficult question. All you have to do is factorize and apply the formula. So I'm saying an easy level of difficulty. to be solved within about 1.5 minutes. What is the sum of digits of the smallest positive integer to have exactly 64 factors? Now 64 can be written as 2 into 2 into 2, 248, 16, 32, 64. 1, 2, 3, 4, 5, 6. This kind of a number will be of the form having 6 prime factors: a raised to power 1 into b into c into d into e into f. So the smallest possibility is 2 into 3 into 5 into 7 into 11 into 30. If we then look at 64 as 4 into 2 into 2 into 2, 4 to the 8, 16, 32. In this case, n will have 4 to the 8, 16, 32, 64. To the rate it was 16 into 2. In this case, there will be 1, 2, 3, 4, 5 factors. So n will be of the form 2 raised to power 4 minus 1, 3 into b into c into d into e. The minimum possibility here will be 2 cubed into 3 into 5 into 7 into 11. Clearly, 2 cube is 8. So 2 into 13 was 26. Now we have 8. Therefore, this will be a larger number than this. The rest is same. So the first case can be eliminated. Then we look at 4 into 4, 16, 32, 64. In this case, we will have 4 factors. So n will be a cube into b cube into c into d. The minimum possibility here is 2 cube into 3 cube into 5 into 7. Now 3 into 11 was 33, 3 cube is 27. So this number will be larger than the new number. So this becomes a smaller number. If we write 64 as 4 into 4 into 4, in that case, we will have n as a cube into b cube into c cube. The smallest possibility is 2 cube into 3 cube into 5 cube. Here 5 sevens are 35, here 5 cube is 125. So this is the larger number, can be eliminated. If we write 64 as 8 into 2, 16 into 2, 32 into 2. Again, 4 prime factors. This can be written as a raised to power 7 into b into c into d. This is the smallest possibility, 2 raised to power 7 into 3 into 5 into 7. 357. 357. So if we compare this number and this number, 357 is there. We have 2 cube into 3 square extra, which is 2 cube into 3 square will be 8 nines are 72. If we take out 357 from here, and here we have 2 raised to power 7. 2 raised to power 7 is greater than 72, so this is a greater number. If we make 64 as 8 into 4, 32 into 2, this will become n as a raised to power 7 into b cube 4 minus 3 into c, which will be nothing but 2 raised to power 7 into 3 cube into 5. Now, if we compare these two numbers, 2 raised to power 7 is same, 5 is same, 7 3s are 21, 3 cube is 27. Clearly, this number is greater than this, so this cannot be the smallest number. So, considering all the cases, we come to the conclusion that this is the smallest number possible, and this is nothing but 2 cube into 3 cube into 5 into 7. So, 2 cube 8 into 27 into 5 into 7, 8 5s are 40, 27 into 7 would be 140, and 7, 140 and 49, 189. 189 into 4 will be 70, 18 into 4, 72, 9 4 36. So 7560. The question says, what is the sum of digits of the smallest positive integer? The answer will be 7 plus 5 plus 6 plus 0, which is nothing but 7, 5, 12 plus 6, 18 becomes the answer to this question. I will call this question a moderate to difficult level of question, because there are always chances of missing out on a case, and therefore if the cases are made properly, that is, start from the smallest value and then start making values or increase values one at a time, you will not miss out on cases, and then the answer will not be very difficult. Otherwise, in such questions, missing out on cases is very easy. In any case, attempt time would be about 2.5 minutes should be good enough. What is the sum of factors of 21600, which are perfect squares? 21600 is nothing but 21600 is nothing but 216 into 100, which will be 6 cube into 10 square, which will be 2 cube into 3 cube. 10 is 2 square into 5 square. So this will become 2 raised to power 5 into 3 cube into 5 square. Now we have to find the sum of factors of perfect cubes squares. There is a direct formula for that. Sum will be, we'll take values or powers which are even. So 2 raised to power 0 plus 2 raised to power 2 plus 2 raised to power 4 cannot go beyond this. 3 raised to power 0 plus 3 raised to power 2 cannot go beyond this. 5 raised to power 0 plus 5 raised to power 2 cannot go beyond this. So this is 2, 4, 8, 16. 16 plus 4, 20 plus 1, 21 into 9 plus 1, 10 into 25 plus 1, 26. 26 into 21 will be 520 plus 26, 546. 5460 simply becomes the answer. And therefore, easy question, because there is a direct formula. Because of the solving time, the attempt time might go up to about 1.5 to 2 minutes maybe, but should be solved because the process is straightforward. How many positive devices does 2021 have? How many positive devices 202? So basically, you have to factorize 2021. 1, 2, 3, 4, 5, 6, 7 does not happen. If we look at the square root of 2021, this will be somewhere around 45 is 2025. This will be somewhere around 45. So I start by looking at numbers near 45. 2021. If we divide 2021 by say 43, uh, 43 divided by 2021 is what I'm checking for. 4s are 160, 172, 301, 721, 1 carry for 2, 20, 30. 340. So 43, 47 both are prime. So basically 2021 is 43 into 47. How many positive divisors? So positive divisors will be 1, 43, 47 and 2021. That is it. 4 positive divisors are there. Again, I checked with smaller numbers very quickly and then started from larger numbers. But if we do check, there is a possibility that reaching 43 might take time. In terms of level of difficulty, the question is easy because we are just checking for whether it is prime or not in that sense. But the solving time might go up to maybe 2.5 odd minutes because we might have to check for almost 13 to 14 prime numbers to reach 43. So that is the only difficulty with this question. But again, if this is a question in the exam, I would solve it because I know the process for the question. I know I will get an answer for sure. So for me, this will be an attempt question. How many integers between 1 and 30, n being 1 and 30, does n have exactly 4 positive divisors? Positive divisors are 4. So therefore, if the positive divisors are 4, n will either be of the form a into b, so that the number of divisors is 1 plus 1 into 1 plus 1, or n will be of the form a cube. We are looking in the range 1 and 30. So here there are two possibilities, 2 cube and 3 cube. 5 cube will be beyond 50, beyond 30. So these are the two numbers possible of the second format. In the first format, n could be 2 into, for B, the possibilities could be 3, 5, 7, 11, 13, and that's it. Beyond 13, the product will cross 30. If A is 3, B could be 5, 7, and that's it. If A is 5, B cannot have any other value. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 such cases are possible. Again, this is a basic question in the sense that you would have done questions like this in the case for 4 positive divisors. is straightforward because there are only two cases possible and the range is also small. So in terms of the concept, maybe a moderate level of concept, but since the values here are small, should be a question that might be solved. 2 to 2.5 minutes should be good enough to answer the question. If a number has 20 factors, what is the maximum number of distinct prime numbers that it can have? So now, if we look at 20, 20 can be written as 20 into 1, or it can be written as 4 into 5, or it can be written as 2 into 2 into 5, or for that matter, it can be written as 2 into 10 and so on. If n is of this form, if there are, n is of this format, the number in itself will be of the format a raised to power 19. Number of factors where a is prime, number of factors will be 19 plus 1. Here n will be of the format a cube into b 4, 3 plus 1 4 into 4 plus 1 5. Here n will be of the format a into b into c raised to power 4, 1 plus 1 2, 1 plus 1 2, 4 plus 1 5. Here n will be of the format a into b raised to power 9, 1 plus 1 2, 9 plus 1 10. Clearly, in this case, the number of prime factors is 1a. Here it is 2, here it is 3, and here it is 4. So what is the maximum number of distinct prime factors that it can have? It can have a maximum of 3 distinct prime factors. Basically, breaking down 20 into the maximum, into a product of maximum numbers will give us the maximum number of prime numbers as well. In terms of level of difficulty, it's an easy question. You would have come across such questions in while practicing, and the value is small, and therefore about 1.5 minutes to get the question done. For how many positive integer pairs mn is 2m plus 5n 99? Now, if 2m plus 5n is 99, we can say 2m is 99 minus 5n, or m is equal to 99 minus 5n upon 2. Now, since we are dividing by 2, the numerator has to be even. If 99 minus 5n is even, that is only possible when, since 99 is odd, 5n has to be odd, and therefore n is odd because 5 is odd, so 5n, for 5n to be odd, n has to be odd. Also, m is positive, so 99 minus 5n should be greater than 0, which means 99 should be greater than 5n. N should be less than 99 by 5 or some 19.8. So the maximum odd value that n can take is 19. It will start going down from here. 17, n has to be odd, n has to be less than 19.8. 17, 15, 13, and so on. The minimum value that n will take is 1 because it has to be positive. And therefore, if we count the number of solutions, we get 1, 3, 5, 7, 11, 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. Basically, 1 plus 9 into 0, 1 plus 2 into 0, max final being 1 plus 2 into 9. So from 0 to 9, there are 10 solutions for n, and therefore correspondingly, we'll have values for m as well. So you'll get 10 pairs of solutions. Again, in terms of level of difficulty, I'd say easy to moderate at max, and the solving time should not be very high because the numbers are small. What is the sum of the positive integral factors of 3 to 88? First, let's try to factorize 3 to 88. 3 to 88 by 2 will be 1644, which can further be divided by 2 to get 822, which can further be divided by 2 to get 411456. This can be divided by 3 to get 137, 7, 10, 11. 137. 137, I think, would be prime. Not divisible by 3, 7, 1 is 7, 67, 9, 11, 13, not divisible. So 3 to 88 becomes 2 cube into 3 into 137. We have to find the sum of positive factors. We have a straight formula for this. Sum of factors is the sum for each of the prime number. We write the sum of all the powers and then multiply them. So 2 raised to power 0 plus 2 raised to power 1 plus 2 raised to power 2 plus 2 raised to power 3 into 3 raised to power 0 plus 3 raised to power 1 into 137 raised to power 0 plus 137 raised to power 1. This will be nothing but 1 less than 2 raised to power 4, which is 8, 4, 12, 13, 14, 15. 3 plus 1 is 4. This is 138. This becomes 60 into 138, which will be 0 in the end. 6 8s are 48, 8 carry forward 4. 6 is an 18, 4. 22 carry forward to 8 to 8 0. And therefore the sum of factors is simply 8 to 8 0. I'll call this a again easy question because the concept is straightforward, direct application of formula. Because we have to factorize 3 to 8, that could be the only challenging part in this question, and therefore I'll say about 2 minutes to solve. How many distinct prime factors does 4 raised to power 5 and 5 raised to power 4 have? 4 raised to power 5 plus 5 raised to power 4. 4 raised to power 5 will be 2 raised to power 2 raised to power 5. This is 2 raised to power 10 plus 5 raised to power 4. 2 raised to power 10 is 1024. 5 raised to power 4 is 5, 25, 126, 25. And therefore the total becomes 1649. Now we have to try and divide this with a number not divisible by 6, 10, 19, 20, not divisible by 3. 137 to the 14, 21, not divisible by 7. Not divisible by 5 and 15, 11. 13 1 the 13, 3, 4, 13 to the 26, 8, 9, not divisible by 13. 17, 17, 9s are 9 1s are 9, 9 are 63. 153, 1, 1. This I think is divisible by 17. 17, 1, 6, 4, 9. 17 9s are 7, 9, 6, 3 carry forward 6, 9, 1, 9, 15, 153, which is 119. 7s are 119. And therefore 1649 is nothing but 17 into 97. Therefore, if you look at this number is 17 into 97. These will be the two. How many distinct prime factors does it have? These are the two distinct prime factors that this sum will have. And therefore, the answer becomes 2. A moderate level of difficulty, the way I solved is the most rudimentary method possible. I found the value and then factorized it. Even then, I don't think it will take more than 2.5 to 3 minutes to solve. So moderate, about 2.5 minutes to solve the question. If you look at the overall test, as I said, moderate level of difficulty, about 23 minutes to go through the paper and get 6 questions net correct. If I had to choose 6 questions, my 6 questions would be 2, 4, 5, 7, 8, 9. Which are these? Again, I'm not counting this question because not everyone will be conversant with this. But yeah, definitely doing this direct formula. Not counting this question because we might miss out on a case. Direct formula, therefore counting this question as an attempt. Uh, again, counting this question, this might take time, but the process is simple and therefore eventually I will get the answer. Not counting this, though this is a simpler question because the numbers are small, but it is easy to miss out on the case. So not counting this as a short question. Not counting this as a short question. Would have done this because here we just had to break down 20. That was the answer in itself. This I would have done simple question. This also I would have done because we just have to factorize 3 to 8. Then there is just the formulas to be applied. So would have attempted this. Not counting this because here the numbers are smaller and therefore my solution was possible. If the number were largest, my solution would not have worked. So not counting this as a short question either. So my short attempt will be 2, 4, 5, 7, 8, 9, which will give me 6 questions net correct for sure.